Hi, grade 12s, and welcome to our section on measurement. As you've seen, we have completed measuring length and distances, mass measurement, measuring volume, which we're going to concentrate more on in this chapter, measuring temperature. But today we're going to concentrate on calculating perimeter area and volume. And as you can see from our syllabus, it involves us looking at complex three-dimensional shapes. So that is what we're going to explore in this module or chapter. So let's get started with your worksheet that you have and go straight to it. Right. So if you look at page 1 of your worksheet that you were given, it's important for us to revise the basic shapes before we can proceed on to more complex figures and shapes. So hence, let's recall and revise area of 2D shapes. Now it's 2D because these are our flat shapes that are drawn on a plane. So we have the square, okay, let me just get back to that. Okay, so our first shape we have is calculating the area of a square. As you can see before you, we have a square measuring 6 centimeters. Do we need to be told the other sides? Obviously not, because the square has all sides equal. So calculating the area would mean that side times side, which would be 6 times 6, which is 36 square centimeters. But for the perimeter of the square, we would add all 4 sides, because that's our definition of perimeter, the distance around a figure. So that would give us 4 times 6, which is 24. Right, so that was easy. Our rectangle, which you would come across in this module quite often, the area of any rectangular shape is always equal to, what's the formula for area of rectangle? Yes, it is length times breadth. So we got length times b. If you look at our figure there, our rectangle, it is measuring 12 times 8, which would be 96 square centimeters. We go to our memo. Now for the perimeter of a rectangle, we see that it's 2 into length plus breadth. Twice the length plus twice the breadth, which is 2 times 12 plus 8, which would be 40. Okay. Now let's look at our next shape, which is our triangle. The area of any triangle, we should be familiar with this formula, which is half base times height. Okay, so in our figure here, the base is 12 and the height is 9. So the formula for the answer to that would be half 12 times 9, which is 54 square centimeters. How do we calculate the perimeter of the triangle? If we start at this point and walk all the way and back to the point, it would mean us adding 16 plus 12 plus 4, 14. Good. So we would get 42 centimeters. Let's move on. If you look at our next basic shape, which is our circle. Now, for the circle, we need to be given a specific measurement, which is the radius, to calculate its area. Because we know that the area of a circle is given as pi times r squared. Right, pi r squared. Now in this shape here, 14 centimeters represents diameter. So our circle radius, we have learned, will be half the diameter. So first of all, there's the calculation there. It is half of 14. Let's make it bigger, which is 7. And stick that in there. Pi times 7 squared. Remember, value for pi will be provided. Now, most of the times it is 3,14 times 7 squared, which is 49. Now, the perimeter formula for a circle can be one of two formulas. 2 times pi times r or pi times d. For convenience in this example here, since we're given the diameter, which is 14, we multiply 3,14 by 14 and 43,96. So the circle formula is, the radius is very important dimension to the circle. Now in figure 5, 6 and 7, we are asked to calculate the area of shaded parts, as you can see here. Now since we do not have a formula just for that region there, we make use of formulas that we know, which are the above. Side times side, length and breadth, or half base times height. Now in figure 5, to calculate the area of the shaded region, we would imagine as if we did not have the circle in the rectangle and calculate the area of the entire rectangle. Since the circular part is removed from that area, we subtract the area of the circle. So our calculation would look as area of the rectangle minus the area of the circle. I'm sure you got that. So there's area of rectangle minus area of circle, which is area of the rectangle, which is 22 times 14 minus 3,14 times 6. In this case, r is 6. And if we calculate 308 minus 113,04, which is 194,96 centimeters squared. So this is what we're heading towards in our work, is applying the basic shapes to more complex, as the syllabus stated, to complex figures. In figure 6, we have a rectangle again, but this time a triangle inscribed in it. So we figured out that we would calculate the area of the rectangle minus the area of the triangle. But now we need to be careful, because in the triangle we're given two sides, and one of them is the hypotenuse, which is not used in our formula to calculate the area of this triangle here. So we need to calculate BC, and that's why you see an extra calculation using Pythagoras' theorem here. Let's go to tools. We have to move each time to this till I get the settings right. So we got Pythagoras' theorem, which won't be provided to you. You've got to learn this theorem here. So we've got BC squared plus AB squared. The two short sides squared add up to the third side, the hypotenuse, AC squared. So BC squared plus 4 squared is 16, equal to 25. So 25 minus the 16 will be 9. So BC works out to the square root of 9, which is 3. And that's what is used in calculating the area of this triangle. It's half base BC times height, which is 4. And now we're able to get to the answer, which is 104 for the shaded area. If we move down to our worksheet, and if we see example 7, we are finding that we have a semicircle and a right angle triangle attached to it. Once again, you are getting familiar with Pythagoras' theorem because the 10 is the hypotenuse. So if you look on my right, QR squared plus 4 squared is equal to 10 squared. So QR squared plus 16 is equal to 100. So QR is equal to the square root of 84, which is a decimal, 9,165, which I've rounded up to 9,17. Now, if QR is 9,17, we need to find half of QR because that would be the radius. And that's how I have the 4,08. Because 4,08, if I fork R, it is 9,17 divided by 2, which is 4,08. And I plug that in there for my area. Now, why do I use half pi r squared? Simply because this is a semicircle. Semi means half a circle. That's why we have half in our formula. We adjust. Area of the triangle, now that we have QR, which is the base, which we found by Pythagoras' theorem, which is half 9,17 times the height 4, and then we add the two to get our area for this region here. So learners, as you see, we went quickly through our basic shapes, which led us to determining areas of complex shaded regions using Pythagoras' theorem in calculating the areas. And also bear in mind that a semicircle is half the circle, which is half the area of a full circle, which is half of pi r squared. In our next part of our syllabus, we are going to look at more complex three-dimensional shapes. But as you can see that we have got several circle questions on this page also. So going back to your question paper on your booklet, we have done the area of figure 7, and in our next chapter, our next video, we'll look at page 2 of your booklet. Right, I want you to practice with these examples and enjoy your learning on area and perimeter and volume, which we will explore in this work here. You need to practice, practice, practice. See you.